Hello, my name is Ramez. In group 35 with Clara and Lucy, we're here to present our project. It's QDoc Quantum Machine Learning Powered Healthcare Platform.
Traditionally, diagnosing a patient's condition has been based heavily on the umbrella approach, which is based on the patient-reported symptoms, resulting in an umbrella diagnosis and general treatment that frequently fails to achieve their intended effects due to individual variability. To exemplify, just in Europe, these failures are responsible for up to 200,000 deaths each year. In addition to that, this approach is time-consuming and highly expensive. Precision medicine aims to tailor prevention and treatment approaches to the individual. Due to the complexity of human biology, individualized medicine requires taking into account aspects that go well beyond standard medical care. In fact, medical care only has a relative contribution of 10 to 20% to outcomes. Health-related behaviors, socioeconomic factors, and environmental aspects account for the other 80 to 9%. So, what are the improvements? The goal of precision medicine is identifying and explaining relationships among interventions and treatments on the one hand and outcomes on the other hand, in order to provide the next best medical action at the individual level. This will leave us for more accurate, earlier, and more granular results. The use of traditional machine learning has helped the progression of precision medicine, but is coming to its limit as the number of health-related variables increase. So, how can we use quantum computing to add this cause and emphasize the interplay of health risk factors in the progression of disease?
As an example of the use of our platform, we're using cervical cancer as a possible disease. Some of its possible risk factors is an infection with HPV, smoking, DES, and lifestyle, such as multiple sexual partners using oral contraceptive and beginning sexual activity at a young age. Other more in-depth factors that could be taken into analysis of cervical cancer shows that there's more interplaying factors, such as whether the person is HIV positive, and further, ERB3, HLA, CASP8, and CHKBP1 could be used to find the predisposition of the person to cervical cancer.
Our solution is QDOT, a quantum machine learning powered healthcare platform. It's a precision-based approach for healthcare. We use a user-friendly mobile interface that will collect a large amount of relevant medical data from our patients, input data like recent symptoms, birth and gender, residence and traveling, lifestyle details, genetic exams, family tree, allergies, and disease history. From there, an assessment is made based off of risk factors for cervical cancer. Some of the medical data collected can be listed here. For instance, this is an example for cervical cancer risk classification. The hybrid neural network solution takes advantage of PyTorch and Qiskit's algorithms to optimize for a risk analysis for cancer detection. QDoc code. Our code is available on GitHub and is open source. On the right, you can see the technical architecture. We have parameters like age, smoking, and HPV. From there, the data is sent to a parameterized quantum circuit, and unitary gates for each parameter matrix is applied to output features like the cervical cancer risk factor and the percentage. As the data about diseases increases due to the high rate of progression in the life sciences, we would be able to integrate all of these risk factors to produce a reliable probability of an individual developing this specific disease. Future plans, individual plan of action. More precise treatments and best outcomes, add better classical data processing, include health diagnosis and medicine recommendations, increase the efficiency of our code, in addition to adding privacy considerations for medical data. QDOT is the way to approach precision-based healthcare. Thank you for your time and attention.